Okay, people, let's have a look at some information here. If we discuss this, well, why is C2 90? Because that's a diameter, and this angle D is 90 given. Also, you've got a tangent, so if you think about it, the angle between the tangent and the chord is equal to the angle in the alternate segment. C1 is equal to A. Okay, now let's have a look. Okay, if you look at your triangles, you've got B, D, and C. Now, B, D, and C would be B2, D, and C1, and then you've got triangle B, C, and A. Okay, now B is B1, C2, and A. Okay, now what do we know? We know that A and C1 are very equal via tan chord. We've got D and C2 being equal because of the 90 degrees, and then obviously B1 will be equal to B2 from the sum of the angles of a triangle. So let's set that out in proof form quickly here. So number A, we can say in triangle BDC and triangle BCA, into those triangles there. Let's just see if we've got the order right there. Yes, we've got it there. Correct. Okay, what do we know? We know firstly, if we look at that number 1, what is the first thing that we know about that? Is we know that angle D is 90, so we're going to develop this. Angle D is 90 and angle C2 is 90. Why is D equal to 90 given? And the reason why C2 is 90 is angle in the semicircle there. Okay, great. So therefore, angle D is C2. They both equal 90 degrees. So we've got that. D is C2. Now, why is C1 equal to A? That's the tan chord theorem. C1 is A, tan chord. So number 2 here, we can say that C1 is A, and that's because of the tan chord theorem. And then the third thing that we can say is that obviously B2 is equal to B1, that B2 and B1 are equal there, and the reason being B2 is equal to B1, that's the sum of the angles of the triangle. And then we can say, therefore, triangle BDC is similar to triangle BCA, 3 pairs of equal angles there. Okay, and then the B part, we're probably going to need to do a frog face. Let's just take that down because we want to see what we have to do. So let's take it down quickly and bring him down to here and paste him and see what we get. There we go. So let's leave him there. And in number B, what we want to do is we want to prove this. Now, if we use frog face, we've got BD over BC is equal to DC over CA, and that equals BC over BA. Okay, now let's have a look at the thing that we want to prove. Well, there's a BD and we've got a BD there. There's a BC which is now underneath. We've got a CD or DC there, and we've got an AC there. So what we can do is we can use this, but now watch this cross-multiplying process. It's brilliant. What we now do is we say, well, look, BD over BC is equal to DC is CD over AC. If you take AC there, you can write it. Now look at this. If you compare this, we've got BD at the top, and there's a BC at the bottom. Now look at this. There's a BC should be in CD's place. So in other words, what we want to do is swap these two around. Okay, we want to swap them around. If we can change their position, we will easily have that there. Now watch this. All you have to do is say, okay, fine, let's swap them. So you say, therefore, BD, bring the CD down and bring the BC up. And if you do that, you've got exactly what you wanted to prove. You see how brilliant that is? That's the shortcuts of cross-multiplying in similar triangles. Okay, guys, stay with us for another lesson where we're going to be locating triangles. They're not going to tell us about the triangles, but we're going to have to find them. So stay with us on Moby School.